This question is from the 2019 exam paper. It was question 10C. Okay, so 25 mark question. When 3.17 grams of mercury thiocyanate is heated in a well-ventilated fume cupboard, it decomposes completely according to the following balanced equation. And they give you the equation. Now, a lot of those things you wouldn't have ever seen. People that sat this leaving cert wouldn't have ever come across mercury thiocyanate before, more than likely. So that's not what we're looking for, though. We're not really been asked anything about the actual compound itself. We're working with numbers here. Alright, what mass of C3N4 is produced in this reaction? So, we're told information about the mercury thiocyanate, and we want to find out something about the C3N4 there at the end. So if we want to find the mass of C3N4, we're going to have to find the moles of it. So that means we're going to have to find the moles of our mercury thiocyanate first. So, part 1. Alright, number of moles is equal to mass over relative mass. So here our mass is 3.17. The relative molecular mass of mercury thiocyanate is actually 317. So that means that we have 0.01 moles of mercury thiocyanate. Alright, so of HgSCN2. Alright, we can see in the equation that they're in a 2:1 ratio. You have 2 moles, or twice the number of moles of mercury thiocyanate as you have C3N4. So that is going to mean your number of moles, your N, number of moles, C3N4. Right, you have half the number of them, so it's going to be 0.01 over 2. And that is going to give you 0.005 moles C3N4. Now, you weren't asked for the moles, you were asked for the mass. So again, we're going to have mass is equal to the number of moles multiplied by your relative mass. So it's going to be 0.005 multiplied by 92, and that is going to give you 0.46 grams. And that's your answer to part 1. And this particular, they actually gave a lot of marks for the first part of it. That part 1 was worth 12 out of 25 marks. So they gave a lot for that. Okay, so they gave 3 for this. They gave 3 there. They gave 3 for this 92. And they gave 3 for the final answer. Okay, so a lot of marks there. Now, if we look at part 2 then. Alright, all the products of the reaction above are unstable, and if heating is continued, these products burn or decompose. So each of these down here, right, your HGS, that's the HGS that's there. Your CS, that's the CS that's there. And C3N4, that's the C3N4 you're after calculating. Okay, so each of the products has a separate reaction. It either reacts with oxygen in air, or it just decomposes. So, what we are saying there really is that because we're after calculating our number of moles up here, right? So we had, what was it, 0.01 moles. We had 0.005 moles. Again, here, we would have had, because it's in a 1:1 ratio with your C3N4, that would have been the same, 0.005. And here, 2, again, so you would have had 0.01 moles of your HGS. Okay, so we have our number of moles now of each. Those number of moles, when we bring them down to the other reactions, they don't change. The numbers in front might change here, but they're just showing a ratio. Alright? But you have the same amount. So the number of moles isn't actually changing when you bring them down. So when you have HGS down here, you still have 0.01 moles. Your CS, you still have 0.005. Our C3N4, you still have 0.005. Because it is the same quantity. It is this C3 and 4, that is decomposing. It is this CS2 that's reacting with oxygen, and it's this HCS that is also reacting with oxygen. So they're the same amount. It's not a different amount of it that you're reacting with. When you bring them down here, it's showing you the ratio of number of moles of your CS to your oxygen, or your HCS to oxygen. And your products, of course. Okay, so those stay the same. So from that, we can actually tell the number of moles of everything that we have down here, and it'll actually help us answer all of our questions. So for oxygen, in the first equation, it's in a 1:1 ratio, so you have 0.01. Same with our Hg and our SO2. Go to a different color just so we can see. Go to red. Alright. 3 times the number of moles of oxygen here as your CS, so it's going to be 3 times 0.005, so that's going to be 0.015. This is going to be 0.005, and this is going to be 0.01, right, because of that ratio. And if we go down to the last line, alright, we'll do the N2 first, so we can see what 1 is at least. Alright, half the number of moles, so half of 0.005 is going to be 0.0025. That's in a 1:3 ratio, or 3:1 ratio with that, CN2. So you're going to have 3 times 0.0025. So it's going to be 0.0075. So we actually have our number of moles of everything now from that. So we look at our questions. How many litres of oxygen gas measured at STP are required for the complete combustion of CS2? So to find your volume, you're going to have your number of moles multiplied by your molar volume at STP is 22.4. So you have 0.015 moles of oxygen gas in that second reaction, because we're talking about the combustion of CS2. That's there. Alright. So it's going to be 0.015 multiplied by 22.4, and that answer is going to be 0.336 litres of O2. And that's that question. What is the number of atoms of mercury what is the number of mercury atoms produced? Our mercury is Hg. That's what we have here. Okay, to find your number of atoms of something, it's going to be your number of moles multiplied by Avogadro's number when it exists as single atoms as it is there. So for this question, it's going to be 0.01 multiplied by 6 by 10 to the 23, and that gives you an answer of 6 by 10 to the 21 atoms of Hg. Alright, and the last question, what is the total number of moles of gas formed? So they're the number of moles of your gaseous products. If we look at these equations, you'll notice that after them they have an L or a G or an S after them. That tells you what state they're in. So our HCS there is solid because it has an S in after it. O2 has a G after it, it's a gas. Hg there is a liquid. So we're looking for our gaseous products. So we're going to be including the number of moles of sulfur dioxide, 0.01, carbon dioxide, because there's a G after that as well. This sulfur dioxide, right, our nitrogen gas, and our CN2 as well. Okay, so you're just adding up the number of moles of each of them that we have, and by going down through the equations before we even started, it's just adding up those numbers. So it's going to be our so the only one we're ignoring really is our there. Okay, the rest of the products you just add up. So it is going to be right, it's going to be 0.01 plus 0.05 and 0.01 plus 0.0075 and 0.0025 and that adds up to be 0.035 moles of gas. So last part, just simple addition. Alright, and that is the 2019 stoichiometry question. Okay, so the only place really you can go wrong, I suppose, is just making sure that you don't change your number of moles when they come down here. Alright, even though the number in front may change, so from here going from 2 to 1, but the number of moles is actually staying the same because it's just showing this ratio in here between all of these. Okay, and that is your 2019 stoichiometry question.